Okay, we're doing some more algebraic manipulation. This will culminate in a test in 3 or 4 days. After 3 or 4 days more of new material. This one, you're going to have to do a rewrite. It's a log right now, and you're going to have to rewrite it as an exponential. So as I do that, I'm going to get rid of the log. That's kind of cool. So it'll just become x minus 2 to the power of 2 is equal to 16. See if you can finish it from there. I'm pause while you do that. Okay, so from here it should be pretty easy. You just put it to the power of 1/2. I'm taking a square root on both sides. And then I get x minus 2 is equal to the square root of 16 is 4. And so then x has to equal 6. False. How many of you thought it was 6? Be honest. Okay. It's really 6 and something else. Not negative 6. Know why? Because we took a square root on both sides. We took a square root on both sides. When you do square root on both sides, we have done this so many times. When you take a square root on both sides, you're supposed to get the absolute value of x minus 2 equals 4. When you take the square root on both sides, you've got to do that. So then that's going to split it into two parts. X minus 2 is either equal to 4 or x minus 2 is equal to negative 4. Do you get what's underneath the blue thing here is either a 4 or a negative 4? Why is that? Because we have it being squared. See how this thing in here is going to get squared, and therefore it can either be 4 or it can be negative 4. Either way it would work. All right, so there's two answers. And the two answers are x equals negative, no wait, add 2 to the negative 2. Or, over here, adding 2 to both sides, x equals 6. So 6 is one of the answers, but negative 2 is the other answer. But then, you're supposed to not only get two answers, you're supposed to notice that when I put it back into the original, 6 actually works. If I put a 6 right here, I get log base 4 of 16. And you know how if this is a 4 and this is a 16, that'll come out to 2, and it works. Yay. Why can't I actually use one of my two answers that I'm supposed to get? See that negative 2 there? You know, if I put a negative 2 right here, that I'm going to have problems? I'm going to have a log with a base of a negative. So, those of you that thought the answer was 6, you got right answer because you just didn't know enough to know better. 6 is the right answer, but so is this until you check it back in the equation and realize that it's, in this case, extraneous. Will it always be extraneous? No. A lot of times both answers will work. But in this case, when I put that negative 2 in, it ends up causing a negative for a base. And if it either that or if it causes a negative for the argument, either way, it's extraneous. So it's more complicated than you might have thought. Why? Watch out for this. Whenever you take a square root or a fourth root or a sixth root or an eighth root, any even root, you need that absolute value thing. Okay? Let's try it again. Let's say it's log base x squared of 32 is equal to 2. You know what? I'm going to change the 32 to a different number because it'll work nicer. I'll change that to a 16. Otherwise, you'd end up with a really weird root kind of answer, and I don't want a really weird root answer. Okay, what you should have said is that to the that is equal to that. X squared to the squared is equal to 16. And yes, I just said to the squared, which is totally wrong. But so that's x to the fourth equals 16. All right, and now here again, I bet some of you just went, oh yay, the answer's 2. Can we just talk about this? When you take the fourth root, that's an even root. Absolute value of x is 2. And then I need two answers. X equals 2. or x equals -2. And some of you might be like, yeah, but those never work. Yes, it does. Both answers work this time. Why? Because when I go back and stick it in the original equation, do you get how when I put in a -2 there, I will never have a problem with a negative base because it's getting squared. And it'll turn out to be a positive number. So I can put negatives or positives in down there. So bottom line is there's two answers that will work for this. Either 2 or -2. Okay, and why? Because right here, most of you, I think, could have got it to there without too much trouble. Many of you would have forgotten to do an absolute value there because we were doing an even root. Now, why do we not have to worry about odd roots? Because the even root thing comes down to this. Do you get how you can't have a negative underneath a square root? Because it's impossible to actually have two things multiply and make -25. Like two things that are the same thing, like 5 and 5 would make positive 25. Negative and negative would make positive 25. This is the reason that these things have to come out with absolute values on them, because you can't have negatives underneath the root. So when you're looking at this kind, cube roots, let's talk about those for a second. It's an odd root. Why do we not have to have absolute values in this kind? Because you can have odd numbers underneath here and it doesn't cause a problem. Why? Because the answer is just simply -2. Because you can actually make it work. -2 times -2 times -2 will equal -8. So you can have the cube root on both sides and be just fine. Thank you very much. I jury rigged it with that. Okay, thanks. Okay, so basically what I'm trying to say is if you're in the middle of a problem like this one and you take any kind of an even root, see, an even root number, like the bottom part's even, then you have to do the absolute value thing. If you ever do one where it's odd, you won't have that problem. So let's do one like that. Log base x plus 5 of 8 equals 3. That one should solve nice and simple. Try it. Grab a pencil, please. I know you're thinking, which is good, but you need to borrow one? Okay. I happen to have. Ready? Oh. That's a basic rewrite. Got to be able to do that. It's going to be on the next test for sure. So that just changed it from a log to something that doesn't have a log in it. Then you got to be able to handle just plain old solving, trying to get this alone. So when you're solving stuff, you go from the outside in. You do the opposite of the normal order of operations. Normally you should do the plus because it's on the inside of the parentheses. And parentheses are supposed to come first. But when you're undoing things, you go from the outside in, or the opposite of the normal order of operations. So anyway, on the outside in thing, I got to get rid of this 3, so I put it to the 1/3 power. And some kid might overthink this and think, oh, so I need an absolute value? Nope, because it has an odd number root. So this becomes x plus 5 equals cube root of 8 is 2. Because 2 times 2 times 2 makes 8. And then subtract 5 from both sides. X equals -3. Is that okay? All right, so now let's check it in the equation. Can I put a -3 right here and still be okay? Yes, I can. Because -3 plus the 5 will make it log base 2. And that's not a problem. Yes? Okay, see the blue writing here where it says x plus 5 to the 3rd? Okay, so what you tried to do is this cubed and that cubed. And you can't do that. That's a really common mistake. It's like saying this, a plus 1 squared. A lot of people think that's a squared plus 1 squared. And it's not. Why? Because it's really a plus 1 times a plus 1. And that's totally different because it's first, outside, inside, last. You end up with a squared plus 2a plus 1. You know what I'm saying? That's where your problems. Okay. So now let's talk about some other kind that you're going to run into. This will drive you crazy in this kind of problem. Because when you try to rewrite it, you end up with something really messy because you have an x in 2 different spots within your log. Like if I try to write this as a log, that's my normal advice to you is rewrite it. That's what we did all day yesterday and until now today. So I rewrite it and I go log base 1/4. And then I go over to the other side and I got to pick up all of this 16 to the 2x plus 1. And then I got to come back over here and take that exponent equals x minus 1. See how messy that is? Holy smokes. Now, could it be done from there? Yes, it could. It could actually, because these two right here share the same base. But if we're going to do it that way, it's better to not even make the log in the first place. So here's what I would propose that we do. If this base and this base were the same, do you remember that's like this? 5 to the x equals 5 to the, or x plus 1, 5 to the 3x minus 5. If they have the same base, do you get I can just cancel the bases? It's not really canceling the bases, but it's just setting this equal to this, and then it's really easy, just solve for the x. So if I could get the bases the same, I'd be good. What base do they both share? And don't say, well, actually, there's 2 bases. 2 works. What else could work? 4 could work. Okay, so if I wanted to change them to 4s, I think that's actually easier. I'm going to take this right here, and I got to write it as 4 to the something. 4 to the what? -1. To the x minus 1. Equals 16 to the 2x plus 1, but I got to erase that 16 and put something smarter. If I want the same base, what should I put there? 4 squared. Do you get how I just made them have the same base? And so now I can ignore this base, and that times that equals that times that. Now I want you to try it from start to finish here. Because the last part, the thing the kids usually forget is you got to distribute this out to both parts. This times this, and this times that. All right, so let's see if you can do this from start to finish. 1/8 to the 2x is equal to 32 to the x minus 2. Try that. I'm going to pause for a second while you do. Okay, so I'm hoping you're thinking, they both seem like they could have a 2 as a base. That's what I was thinking when I wrote it anyway. So 1/8, that's 2 to the something. To the 2x. So 2 to the what? 2 to the negative makes it a fraction. 3. Very good. Why? Because 2 cubed is 8, and then the negative makes it 1/8. Very nice. This other one could be 2 to the 5th, and then it's to the x minus 2. Final answer is that since these guys are the same base, I can now set that equal to that. Do you guys know how I can make that permanent? The calligraphy pen, I kind of like it. I don't remember how to make that set as a default. But I want to, when I pick up a pen, I want it to automatically that. Yeah, I'll figure it out. Okay, so then this negative 3 times 2x makes negative 6x equals x minus 2. And now I just have to, 5x minus 10, thank you. In my obsession with my calligraphy pen, I forgot the 5 was there. Okay, and now I'm going to go, I got x's on both sides, get rid of the smaller one, that's smaller, so I'm going to go plus 6x plus 6x, 0 equals 11x minus 10, and then I'm going to add 10 to both sides, 10 equals 11x, then I'm going to divide by 11, final answer is x equals 10 11ths. Yes, sir. Yep. Back up to the top. Yes? Yes, if you used 8 as a base, I'll just do the beginning of it, okay? Because it'll take a while if I do it the whole way. But if I decide to try to just make this blue problem work out with 8 as a base. Okay, so then this first one would become 8 to the negative 1. And what would this become? That's a tougher one. No. 8 to the 1/2 means the square root of 8, and the square root of 8 is not 32. So if I want to write 32 as an 8 to the something, it can be done. I'll show you. 8 to the something has to be 32. Do you get how I can now kind of think it through and make two common bases out of this thing now? And then I could say, oh, that's 2 to the 3rd to the x has to equal 2 to the 5th. And so then 3x has to equal 5. So 3x has to equal 5. So x has to equal 5/3. So, yes, if you put 8 to the 5/3 power, your little theory could work. But it's tough. All right. Okay. So, the common base thing is a big one. And then here is one that stumped me for a while. I was trying to find common bases for this one. See if anybody's smarter than I am on how to find a common base so that 1/5 and 1 can have a common base. Oh, he looks up with intelligence in his eyes. So what do you think the answer to this thing is? You're onto something, but you haven't got it all the way. Oh, what is it? Don't tell me a long explanation. It's 0. See, I was torturing myself with this just like you were there for like a minute. I was like, okay, common bases. That's like the whole theme of the worksheet. But whenever this is 1, what's the answer automatically? 0. So if you wanted to force your way into it, you could go, okay, that equals x. You could go 1/5 to the x equals 1. And then you could say, wait a minute, the only thing that works here is if I put 0. And yes, the answer is 0. That's right up along the lines of if you have a negative number right here, what's the answer automatically? Undefined. If there's a negative number right there, answer automatically? Undefined. Can you put 0 here? No, you can't. Otherwise, it's undefined. Nope. Can't have a base of 0 either. Automatic undefined. All right. Moving along. Let's see. There's one more kind of problem that I wrote down for myself that I knew would annoy you on today's homework. Which one was it? Ah, yes. Okay. Would you agree that 5 equals 2 plus 3? Okay. Did you know that I can take the log base anything, I'm going to say 4, of both sides of this, and it'll still be true? You can put a log on both sides. Can you believe that at least? Okay. Now, last thought on this. If I can put a log on both sides, I can also get rid of a log on both sides. So if I had a problem that said log base 4 of 5 is equal to log base 4 of x, for instance, if there's a log on both sides like this, that's the exact same base and everything, do you get how if log base 5 of 4 and log base 4 of that has to be a 5, doesn't it? Just by logic. If this one's log base 4 of 5, this one has to be log base 4 of has to be 5. So do you get how it's kind of like canceling these off? Even though it's not really canceling them off, it's just really saying that this has to equal this. It's a lot like when we have this deal, 5 to the x equals 5 to the 7th. You're really technically not canceling these 5s. But it kind of has the same effect because really what's happening is that x has to equal 7. Along those same lines, if you have this, log base e of 4 equals ln of x, do you get that log base e and ln are the same exact thing? So it's like canceling them, but it's technically not. It's just that this has to equal that, so x must be 4. So of course the problem won't be that simple. It might be something like this. What do you think? think the answer is what? 8? Not correct. 15. How can it be 15? Because you remember when stuff is added together, you can combine it into one log and make it log, and then it's not 5 plus 3. You make it a log 5 times 3. You know what I'm saying? This is just what we did 2 days ago. Combining, condensing. 2 was 2 logs, now it's down to 1. If it's an add, it turns into a multiply. Remember that? And then you also have to lose that thing I just told you. If these are the same bases, we can just say that equals that. So x equals 15. So another one like that. Try this. This one's going to be a little more fractiony. Log base 3 of x minus log base 3 of 5 is equal to 25. Nope, I'm wrong. Sorry, log base 3 of 25. There we go. And the people who think that you can just go, oh, doink, a doink, a doink, x minus 5 equals 25, you're wrong. Very wrong. So what can you do? That can be mushed together into one log. Log base 3 of what? What's the minus become? Divide. X over 5 is equal to log base 3 of 25. Now I can doink, and I get x over 5 equals 25. And so if x over 5 has to equal 25, I just have to figure out what 25 times 5 is, and I'll have it. What is it? 125. How did I do that? By getting rid of the logs, by canceling them out. And it's really not canceling. It's really just saying that this has to equal that. All right. I think I've taught you enough stuff that you can handle the worksheet. Here comes the worksheet. You can put away your notes if you want to. And we'll do the first couple problems together. Problem number 3 is a repeat. Like when the teacher was making the worksheet, they were intending to change it, but then they forgot to. So we're going to skip number 3. Okay, here we go, number 1. Number 1 on today's worksheet, which by the way is called 3.5 worksheet number 2. This is ln x squared equals 6. First thought, rewrite. And what's the base on an ln? Base e. I told you anytime you saw ln, you could write log base e. So this is e to the 6th equals x squared. And then, what do you do? How do you get, what's the point of these? I know some of you are afraid of that e. E's just a number. Which one are we trying to solve for? X. So get the x alone. So how do I get that 2 off of there? Square root. And do you remember something about harping at the beginning of the hour about when you take the square root on both sides? Remember what happens? Get the absolute value of x is, and then 6 and the 1/2, when you multiply them, you know, these get multiplied, right? That means e to the 3rd. So I'm really close to done, but there's really 2 answers. X equals e to the 3rd, and yes, just a number. It's 2.718 to the 3rd. And you don't have a calculator for the test, so you can leave it as e to the 3rd. And then you have another one, though, because it was absolute value. There's 2 answers. That and x equals negative e to the 3rd. Now I ask you, since e is just a number, can I put a negative for x? Just look. Is it okay to have a negative thrown into this equation? Yes, there is. It is, because it's going to get squared. So you'd need both answers. A lot of kids would have thought it was just e to the 3rd. It's e to the 3rd and negative e to the 3rd. It's really easy to forget. In fact, I think he might have even forgotten to do that, but it's true. We know it's true. Think about it. If e to the 3rd could work, then e to the negative 3rd is going to act exactly the same way, because once you square it, the negative is going to go away. All right, moving on. Let's go on to number 6. We did ones just like this before in class. 1/4 to the x minus 1 is equal to 8 to the 2x minus 1. So we need a common base. What are you thinking, 2 or 4? 2, because you can't make a 4 turn into an 8 really easy. But you can make a 2. So I'm going to take this out and make 2 to the, it needs to be a fraction, so it needs to be negative. 2 to the negative 2, very good. And that's put to the x minus 1 is equal to, and as 8, I got to replace, that's a lot easier. 8 is 2 to the third. And then I have that to the 2x minus 1. Be careful. All we were doing is replacing the 1/4 and the 8. So all this other stuff, like up here, that had to stay in the product. Then my bases can cancel, sort of. And what I have is this equals this. And that's just a little equation. Don't forget to distribute the negative 2 to both parts. So it's negative 2x plus 2 equals 6x minus 3, not minus 1. But you're multiplying it all out. And then from there, if you can't handle solving that, you really don't deserve a good grade in Precalc. Because this is algebra, and you can handle it. Not saying you wouldn't make a mistake from time to time. You see me make them all the time. Once you get it to an equation, you should feel like confident. This is good. I can handle it from here. All right. And I think it's a very reasonable worksheet. There's a few on here that are undefined, so watch out for that.